In this video, I will be discussing about conic section. The history of conics can be traced back to the ancient Greeks when Apollonius of Perga, during the 3rd century BC, wrote an extensive treatise on these curves which he called conic sections. In fact, he was able to produce 8 books and about 400 propositions or theorems about it. Apollonius is credited for giving them names such as ellipse, parabola, and hyperbola. Geometrically, a conic is a curve traced by the intersection of a plane, a cutting plane, with a right circular cone. Actually, a plane is made to cut the 2 inverted right circular cones. As you can see here, this is 2 cones that are connected at their vertices here. The cones are called napes. The 4 basic conics generated can be illustrated here. So I'll show to you how these conics can be generated by these 2 cones that are connected at their vertices. Now, look at this conic. You can see there that this line that is at the center of the conic, it's an imaginary line. We call this one as the axis of the conic. And we call this cone, the upper cone, as the nape of the cone. So nape of the cone, or in other words, this is because it is found at the upper nape of the cone. And also this one is called as the lower nape of the cone. Now, what if I will draw a cutting plane that is perpendicular to the axis of the conic? So, suppose my cutting plane is like this. So you see, that's my cutting plane. Now, the intersection that is being made by this cutting plane to the cone has a form like this. This one. But remember that this cutting plane is perpendicular to the axis of the conic. So, if you place this cutting plane here and trace that red line here, you form this figure. What did you form? You form what we call a circle. So, the intersection between the cutting plane and the cone is a circle. So, the circle can be traced by the cutting plane and the cone if the cutting plane is perpendicular to the axis of the conic. Now, I have here a second drawing, replica of this cone here. Suppose my cutting plane is not perpendicular to the axis of the conic, but it's parallel to the side of the cone. So this is the side of the cone, and if I will draw here, I will cut here, my cutting plane is here, there. What figure can I make? So you see, that's the intersection that is being traced by this cutting plane, and the cone is like this. If I'll place it here and you are at the top, you can see that the figure form is like this. So what figure is that? That is a parabola. So that's why a parabola is called a conic section. Now, what if my cutting plane is not parallel to the side of the cone, and it's not also perpendicular to the axis of the conic. So what if my cutting plane is like this? Like that. What is the curve traced by this intersection? The curve traced by this intersection is like this. So if you place this cutting plane here, you can see that the curve form is like this. So obviously it's not a circle, but it's what we call an ellipse. So what is an ellipse? An ellipse is a curve traced by the intersection of the cutting plane and the cone. Two cones intersected at their vertices. However, if I'll cut this cone, two intersected cones, by a cutting plane that is parallel to the axis of the conic. So if I'll have here a cutting plane here, like that, what figure, what section can I make, can I trace? I have here a section like this. So if you place this one here, what figure can you form? Actually, you form like this. So what do you call this one? We call this one as the hyperbola. So what is a hyperbola? A hyperbola is a curve traced by the intersection of the cutting plane when the cutting plane is parallel to the axis of the conic. So may I summarize everything? When the cutting plane is perpendicular to the axis of the conic, the intersection, the curve that is traced by the intersection is what we call a circle. However, if the cutting plane is parallel to the side of the cone, the intersection traced by this cutting plane is a parabola. But if the cutting plane is not parallel to the side nor perpendicular to the axis of the conic, you form a curve that is traced by this intersection, a curve called an ellipse. However, if the cutting plane is parallel to the axis of the conic, you form a curve that is being traced by the intersection of this cutting plane, and the curve form is what we call a hyperbola. However, there's a little what we call a special case here. When the cutting plane intersects at the vertex here, what figure can you form? You form just a point. And what do we call this figure? We call this one as the degenerate case. You cannot form a circle, but you can just form a point. And the point, which is the graph, the curve that is being traced by this cutting plane, is what we call the degenerate case of a circle. It's a circle without any radius. So it's a degenerate case. Now, what figure can you form if the cutting plane falls along the side of the cone? You form not a parabola, but you can form there just a single line. Why? Because if the cutting plane is cutting the cone at the side, the cutting plane touches the cone in just a single line. So you form just a single line. Now, if the cutting plane is not perpendicular to the axis of the conic, not parallel to the side, but it passes through the vertex, what figure can you form? I think you can guess that you can still make, you can have the intersection of a point. And that is also a degenerate case. What if this cutting plane, cuts the two cone at the vertex, but the cutting plane is still parallel to the axis, but it passes through the vertex? Now, what figure can you form? You form just an intersection of two lines. So what you can form, instead of having this, you form just an intersection of two lines, two intersecting lines, and that is still a degenerate case. So two intersecting lines there. So analytically, a conic can be described by a quadratic equation of the general form ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0, where a and c are not both 0. So to continue, it is defined as the set of all points in a plane whose ratio of the distances from a fixed point and from a fixed line is constant. The fixed point is called the focus, and the fixed line is called the directrix. And the constant ratio is called the eccentricity of the conic. So, to illustrate, suppose we'll draw here a line. And this line is called the directrix of the conic. Directrix of the conic. So, if I have here a curve, or specifically we call it a conic, there is what we call a fixed point, and this fixed point is what we call the focus. So let's represent this point as point F, and this line as the line D, because this is directrix of the conic. Now, if this is the conic, and if I will identify here a point on this conic, say point P, so it has coordinates of x and y. So the distance of this point from the focus, so here, and the distance of this point from the directrix, which is the straight line. When we say distance from a straight line, it's the perpendicular distance. The ratio is what we call the eccentricity of the conic. So how will I write that one? Eccentricity is equal to PF, the distance of a point on a conic from a fixed point, and the distance of this point on the conic to the directrix. So we say that's PD, is what we call the eccentricity of the conic. And remember, according to the definition, it's constant. So this is constant. So that is the mathematical definition of a conic. So may I repeat? A conic is defined as the set of all points in a plane whose ratio of the distances from a fixed point and from a fixed line is constant. So point from a fixed point, called the focus, divided by the distance of this point from the directrix, a fixed line, the ratio is what we call the eccentricity of the conic. And that eccentricity is constant wherever is this point along this conic, the curve there. So take note that the eccentricity of the curve dictates the kind of the conic. Why? Because if the eccentricity is 0, then the conic is a circle. But if the eccentricity is equal to 1, then the conic is called a parabola. However, if the eccentricity is less than 1 but greater than 0, because if it is 0, it's a circle, then you can have a conic that is called an ellipse. If also the eccentricity is greater than 1, then the conic is what we call a hyperbola. So different values, different ratios from the fixed point and its distance from a fixed line. If the eccentricity is 0, the ratio is 0, then it is a circle. If the eccentricity is 1, then it is a parabola. If the eccentricity is less than 1 but greater than 0, then you have an ellipse. If the eccentricity is greater than 1, then you can have a hyperbola there. So, moving on, what is a circle? Mathematically, a circle is a set of all points on a plane that are equidistant from a fixed point on the plane. The fixed point is called the center of the circle here. And the distance from the center to any point of the circle is called the radius of the circle. So, if A is equal to C, what is this A? The A of the general equation of the conic. So, if A is equal to C and B is equal to 0, in the general equation of the second degree, then the equation becomes like this. So, what was that equation? The equation was ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. This is the general equation of the conic. Now, here if A is equal to C, so when they are equal, I can substitute A here. Instead of writing C, I will write A. Why? Because A is equal to C. So instead of writing C, I will write A because they are just equal. And remember, B is 0 also. So what we have is ax squared plus ay squared plus dx plus ey plus f is equal to 0 because A is equal to C and B is equal to 0 in that case. Now what if I will divide both sides of the equation by A? So ax squared plus ay squared plus dx plus ey plus f. Suppose I will divide both sides of the equation by A. So if I divide A at the left, I will divide also A at the right. So what will I get is this A cancels with this A. So what will remain is x squared, and also this cancels here. So plus y squared plus d over a x plus e over a y plus f over a is equal to 0. Why? Because 0 divided by the number A is 0. Now, suppose I will, because this is just a ratio of two integers, I can replace that one with some variable d, so dx, and this also, I can replace that by some variable e, small e, and also this one as a small f. So, what is the resulting equation? The resulting equation is what we call the general equation of a circle. So this is the general equation of the circle. However, if you wish to transform it to its standard equation of the circle, this equation reduces. So if you manipulate that one algebraically, in which case I will not do it here, however, I do it in my university class, in my university, this can be reduced to a form x minus h quantity squared plus y minus k, some constant k, is equal to r squared. So what do we call this equation? This is the standard equation of the circle. So we call this one as the standard equation of the circle, where the center is at the point hk. So this one, h and k, is the center of the circle, and the radius r. And of course, that should be greater than 0. But what if the center happens to be at the point of origin? Also, it reduces to just x squared, because this becomes 0. So x minus 0 is x, and x squared is this. Plus, also if this is 0, that reduces to y squared equals r squared. And again, this is a standard equation of a circle, but whose center is at the point of origin, and whose radius also is r here. And of course, it should be greater than 0. So to illustrate, I will be giving you examples. So suppose this is our example 1. Determine the general equation of the circle with its center at point -2, 3, and a radius of 4. So how will you find the general equation of the circle? So first, to solve this problem is to identify first the given things in the problem. We are given that the center is at a point -2, 3. And also we are given that the radius is 4. So if that is the case, I can use the standard equation of the circle, which has a formula x minus h quantity squared plus y minus k quantity squared is equal to r squared. And substituting this value, because you know h, k is the center of the circle in standard form, so this is our h and this is our k. So if I substitute that one, x minus the -2, so I may place that one inside the parenthesis because that's negative. So x minus the -2 quantity squared plus y minus 3 quantity squared is equal to 4 squared. Now if I simplify this one, the minus of the -2, so the minus of the minus becomes positive. So x plus 2 quantity squared plus y minus 3 quantity squared is equal to 16, because 4 squared is 16. So this time, we need to square first this binomial. So squaring that binomial, we have x squared plus 4x plus 4. And you can check that this is the square of this binomial. How will you get that? You square the first term, and that's x squared. And how will you get 4x? You multiply the first and the second, and then twice. So x times 2, 2x, and then twice of 2x, it's 4x. And then square the second term. Same method we do here for the second binomial. So we square that one, and you square the first term, that's y squared. Multiply the first and the second, so y times the negative 3, so that is negative 3y, and then twice of that, so minus 6y there. And then you square the second term, and the square of 3 is 9. So you can check that this is the square of that binomial, and this is all in all equal to 16. So if you combine similar terms, so x squared plus y squared here, x squared plus y squared plus 4x here, and minus 6y, and then I'll add 4 and 9, which become 13, and then that is equal to 16. So combining all the constants, what you will do is to subtract both sides by 16. So x squared plus y squared plus 4x minus 6y plus 13, I will subtract 16. So if I subtract here 16 also, the left, I will subtract 16 to the right. So what will remain is x squared plus y squared plus 4x minus 6y, and 13 minus 16, it's minus 3 equals 0. So this is the general equation of the circle when the center is at the point negative 2, negative 2, 3, and having a radius of 4. And if you want to see that one in a graph, sketching the graph of this circle when the center is at the point of negative 2, 3. So if this is the point of origin, so you count 2 units to the left and 3 units upward. So 1, 2, and 3. So here is the center of the circle. Is at the point negative 2, 3. And it has a radius of 4. So from the center, you count 4 units. 1, 2, 3, 4. And then you count also to the right. 1, 2, 3, and 4. You count also 4 units to the left. 2, 3, and 4. You count 4 units to the right. 2, 3, and 4. Then you can form a circle here. So how will I draw the circle? I just approximate drawing of a circle there. So this is the graph of the circle whose center is at the point negative 2, 3. So this is the center, and it has a radius of 4. And that's it. Now let's proceed to the second problem. So this is my number 2 problem. For the circle whose equation is 3x squared plus 3y squared minus 2x plus y minus 5, which is equal to 0, find the coordinates of the center and the length of its radius. So how are you going to solve the center, the coordinates of the center of the circle and the length of its radius when you are given the general equation of the circle? So to solve this problem is to write this general equation: 3x squared plus 3y squared minus 2x plus y minus 5 is equal to 0. And then my objective is to transform this one to standard form, because in standard form you can determine the center and the radius. Can you recall the formula of the standard equation of the circle? The formula is x minus h quantity squared plus y minus k quantity squared equals r squared. So if you can convert this one like that, then you can identify the center because the center is here. The number that is subtracted from x under this square. And so with this one, a number that is subtracted from y under this square. And the radius is the root of this r squared. So what will I do to convert this one like that? First, I need to remove this 3. This number 3, the coefficient of x squared, and the coefficient also of y squared, which is 3. So what will I do? I will divide both sides of the equation by 3. So there. I will divide 3 at the left side of the equation. Also, I need to divide 3 at the right. So when 3x squared divided by 3, what will remain is x squared. And 3y squared divided by 3, it's y squared. But I have here 2 divided by 3, so that is 2/3 x. And then I have plus y over 3, a third of y, minus 5/3 equals 0. Now, next is to rearrange the terms so that I can form like this. So I group all the terms having x and all the terms having y. So x squared minus 2/3 x here together. And then I group also the y squared plus y over 3 because these are terms having y's as their coefficients. And then I can add both sides of the equation by 5/3. So if I add 5/3 at the left, the 5/3 here, the negative 5/3 and 5/3 cancels each other. So, and I have here 5/3 at the right. Now what will I do is to make this one a square by adding a third term to make it what we call a perfect square trinomial. Also this one I need to add a third term to make this as a square. So my objective is to make this one like this and to make this one like that. So what will I do to determine the third term of this trinomial, expected trinomial, is to divide the coefficient of this x by 2. So 2/3 divided by 2, that makes 2/6. Because 2/3 divided by 2, it's 2/6, and you need to square that. That's the rule. Get the half of this and you square. That's the one that you are going to add to make it a complete square. Same with this. This is 1/3 y. So if you divide 2 to this 1/3, that becomes 1/6. And then you square. And because I add 2/6 squared and 1/6 squared at the left side of the equation, you might wonder, where did I get these numbers? So what will I do to make it balance? I will also add here at the right 2/6 squared and 1/6 squared to make it balance, to make this equality hold. Because I add 2/6 squared at the left, 1/6 squared here, I add also same amount at the right to make the equation balance. So what will I get is x squared minus 2/3 x plus, I can reduce this like 1/3 quantity squared because the reduced form of 2/6 is 1/3 plus y squared plus y over 3 plus 1/6 quantity squared, which is equal to 5/3, and the 2/6 becomes 1/3, and 1/3 squared it's 1/9, and 1/6 squared becomes 1/36. And then you can simplify that this one can be written as x minus 1/3. How did I determine those terms? I get the root of x squared, which is x. I get the root of 1/3 squared, which is 1/3, and I copy the middle sign. And you can check that this one is just equal to that. Also, this one, I can rewrite this like y, because the root of y squared, which is y, and the root of 1/6 squared is 1/6. I just copy the sign of the middle term, which is positive. So I square this one, and you can check that this one is just equal to that one. So at the right, I can combine them and look for the least common denominator, which is 36. 36 divided by 3 is 12, times 5 is equal to 60. And 36 divided by 9 is 4, times 1 is 4. 36 divided by 36 is 1. 1 times 1 is 1. Now my objective is to convert this one like that. So don't forget the plus sign. So this is x minus 1/3 quantity squared, but this one should have a form, this one, y minus k quantity squared, but this is positive. So to make it a minus, y minus the negative 1/6. So that's the technique to convert this like a minus. So minus the negative 1/6 is the same as plus 1/6. So quantity squared, and you can check that this one is just equal to that. And this is 65/36. Now, this time, I can rewrite this, the right side of the equation, like a square. How will I make this one a square? So if I square that one, you might wonder, where did I get the square? So to make it a balance, I take the root of this, the square root of that, and then you square is just equal to that. Hence, I can say that the center of the circle is at the point 1/3, this one, the number that you subtract from x, and the number you subtract from y is the y coordinate for your center of the circle, which is negative 1/6. And then you are having a radius of the square root of 65/6, because the square root of 36 is 6. And that's it. Now, if you want to see that one in a graph, now take note that the center is at the point 1/3, negative 1/6. So if this is 1, and this is negative 1 in the y-axis, the x-coordinate is 1/3, so somewhere here. But the y is negative 1/6. So let's just estimate that this is the center of the circle, 1/3, negative 1/6. Now it has a radius of square root of 65/6, which if you can check this one to your calculator, this is 1.34 something. So let's just estimate that that's 1.3. So here, if that we count 1 and then 0.3 somewhere here. So that distance, and that distance, you can form a circle in this drawing here. So let's just make an approximate drawing of the circle. But you can do this one using a compass. just place here, and then the radius, get the length of the radius, and then you can draw using your compass. So that's the graph of the circle having a center at 1/3 negative 1/6, and it has also a radius of the square root of 65 over 6. That's it. So let's proceed to the number 3 problem here. So this is our number 3. The point negative 2, 3 lies on the circle with the equation x squared plus y squared minus 4x minus 2y equals k. Determine the center and the length of its radius. So how will you solve this problem? To solve is to use the given things in this problem. We are given that the equation of the circle is x squared plus y squared minus 4x minus 2y is equal to k. What makes it a problem is that we don't know yet the k. So our objective is to convert this one into standard equation so that I would know the center of the circle. So how will I convert that one into standard form? So remember the standard form, the standard equation of the circle. So what was that formula? That was x minus h quantity squared plus y minus k quantity squared is equal to r squared. So what will I do here? I will group all the terms having x. So x squared minus 4x here, group them. And then I group also terms having y. So y squared minus 2y there. However, I need to have a square for your x. So what will I do is to complete this one to become a perfect square trinomial. So I need to add something which I don't know yet. So also this one I need to add something which I don't know. So here this is equal to k. So to get this third term, I told you that you divide it by 2, the coefficient of the second term, you divide it by 2 and then you square. So if I divide it by 2, negative 4 divided by 2, it's negative 2. And when I square, that's 4. So that is x squared minus 4x. I need to add negative 2 quantity squared. Why? Because negative 2 is the half of negative 4, and then I need to square them. So plus y squared, I just copy the y squared here, minus 2y, but I need to divide negative 2 by 2. So negative 2 divided by 2, it's negative 1, and when I square, that's positive 1. So I will add here negative 1 squared, which is equal to k. But I added here these two numbers at the left. So to make it balance, I will add also same numbers at the right. There. So next I can rewrite this trinomial as a square of the binomial. So how will I do it? I get the root of x squared, which is x. I get the root of this one, which is 2, but I get the sign of the middle term, quantity squared. And you can check that this one is just equal to that. So to check, the square of the first term is x squared. Multiply the first and the second, and then twice, and you get negative 4x. And then you square the second term, which is that. Also, I can rewrite these 3 terms as a square of a binomial. How will I do it? I just get the root of x squared, which is y, and I just get the root of this, which is minus 1. So when I square this one, and you can check that this one is just equal to that. So at the right, I realize that the square of negative 2 is 4, and the square of negative 1 is 1, there. So this is x minus 2 quantity squared plus y minus 1 quantity squared, which is equal to k plus 5, there. So what's next? Remember that we are given this point, and this point lies on the circle. And since this point negative 2, 3 lies on the circle, then it satisfies the equation, the resulting equation. So if you substitute this one in this equation, you will get, so substitute your x here, so that's negative 2 minus 2 quantity squared. So instead of writing x, you will write the x here, and then plus y. Instead of writing y here, you write the value of y, which is 3. So 3 minus 1 quantity squared, which is equal to k plus 5. Now to continue, minus 2 minus 2, it's minus 4 quantity squared. And then this is 2 squared, which is equal to k plus 5. And negative 4 squared is 16 plus 4, because 2 squared is 4, is equal to k plus 5. So when I subtract 5 to both sides, so 16 plus 4 minus 5, and here k plus 5 minus 5, it cancels the 5. So what will remain is k. So k is equal to 15. Now that I know k, I can substitute the value of my k here. So substituting k, which is equal to 15, to this equation. So what equation? This one. So x, because this is the standard form of this general form. So x minus 2 quantity squared plus y minus 1 quantity squared. Instead of writing k, I will write the value of k, which is 15. So 15 plus 5. And you might wonder why I use this and not the original equation. Because my objective is to look for the center. I cannot find the center when I will be using the general form. So it should be in standard form, because the number that will be subtracted to x and the number that will be subtracted to y under these squares will be the center of the circle. But the problem here is that I don't know what is k. Now that I know k, I can substitute k there, so I can solve this one. So x minus 2 quantity squared plus y minus 1 quantity squared, which is equal to 20. And I can rewrite 20 as a square number. How will I do that? I just take the square root of 20 and I square this one, so that the square of the square root is 20. So I would know that the center is at the point 2, 1, because of this, the number that is subtracted from x, and also the number that is subtracted from y. So the x coordinate of the center is 2, and the y coordinate of the center is 1. So also the radius is the square root of 20, or if I factor out 20, in which one of the factor is a perfect square, that is the square root of 4 times 5, and the square root of 4 is 2. So 2 square root of 5 is the radius of the circle. And if you're going to see the the graph of this, so what's the graph of this? If I graph this one here, the center is at the point 2, 1. So you move 2 units to the right from the origin and then 1 unit upward. This is the center of the circle 2, 1. But it has a radius of 2 square root of 5, which approximately, if you have your calculator, this is 4.47. So almost 4.5. So you count 1, 2, 3, 4, 5. And then because we don't have space, you can estimate the radius and form a circle there. And that's it. So let's move on to our number 4 problem. Find the general equation of a circle having these 2 points as the ends of its diameter. So first and foremost, to solve this problem is to, maybe if you don't know how to solve, is to visualize, draw the things that are being described in the problem. So you need to plot these 2 points. So where is that negative 5? So you move 5 units to the left because it's negative. So negative 5, and then move 5 units upward because that's positive 5. 2, 3, 4, and 5. There. Also, you need to plot the second point, which is 1, negative 3. So 1 unit to the right, and then 3 units downward. So 2, and then 3. So this is the point 1, negative 3. Also, this point is having coordinates of negative 5, 5. So remember that these 2 points are the ends of the diameter of this circle. So if I draw a line segment, a broken line connecting these 2 points, that is the diameter of the circle. So if I may estimate, I think the circle is this one, like that. So what can you conclude based from the drawing? You can conclude that at the midpoint of this diameter is the center, of course. So the half of the diameter is the radius of the circle. So if I would know that center C, then I would know the radius, because the radius is just the distance of the center to any point on the circle. So how will you get the center? So to get the center of the circle, I will use the knowledge you've learned from your junior high, which is how to find the midpoint of a line segment. So to find the midpoint, the x-coordinate of the center is, I need to add the x-coordinates of the 2 points, which is negative 5 and 1. So this negative 5 and the 1 here, and then divide it by 2. So you just get actually the average of the 2 numbers, which is negative 4 over 2. And if you divide, that's negative 2. Also, for the y-coordinate of the center, is just the average of the y-coordinates of these 2 points. So that's 5 and negative 3. So 5 plus the negative 3, which is minus 3 over 2. And that is 2 over 2, which is equal to 1. Thus, I would know that the center of the circle is having coordinates negative 2, 1. And as you can see, it's very realistic to our drawing. That's 2 units to the left and 1 unit upward. So here, I know that the center is at the point negative 2, 1. Here. So next, I can solve for the radius of the circle. So solving for the radius is to use the distance formula you've learned from your junior high. So the radius is the distance of the center to any point. So I can find the distance of this point from this point or from this point. Suppose I will use this point. So what point? The center, which is -2, 1, and the point 1, -3. So using the distance formula, which is r is equal to the square root, and you know, and I know you can remember this one, x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. You just substitute the coordinates of the 2 points. Now whichever comes first, where is the first point and where is the second point, it doesn't matter so long you are consistent for your x's and for your y's. So if suppose I will choose this one first, so -2, I will choose also this one next. So -2 minus 1 quantity squared, because I get this point first, so I will get for the y this point first. So 1 minus the -3 there. So r is equal to the square root of -3 quantity squared plus 1 plus 3, because 1 minus the -3 is the same as 1 plus 3 quantity squared. Now I know that this is equal to 3 squared, -3 squared is 9, and 4 squared is 16. That I know that the radius, the square root of 25, because 9 plus 16 is 25, and the square root is 5. So the radius is 5. Now that I know the center and the radius, I can solve for the general equation of the circle, because the problem is asking for the general equation of the circle. So I can use the standard equation of the circle, which is x minus h quantity squared plus y minus k quantity squared, which is equal to the square of its radius. So substituting the center, and I know that the center is this one. So what is my x coordinate of my center? -2. So minus the -2 squared plus y minus the y coordinate of my center, which is 1, quantity squared, and my radius is 5, so 5 squared here. So to simplify, this is x plus 2, because x minus the -2 is the same as x plus 2 quantity squared plus y minus 1 quantity squared is equal to 25. So if I square this binomial, I will get x squared plus 4x plus 4. And you can check that this trinomial is the same as this square of this binomial, plus this one also, which is equal to y squared minus 2y plus 1. And you can check that this trinomial is the same as the square of this binomial, which is equal to 25. So combining similar terms, I have x squared plus y squared there, plus 4x here, minus 2y, and 4 plus 1, which is 5. And then this is equal to 25. Subtracting both sides of the equation by 25, I will have 25 to subtract at the left, and nothing at the right because 25 minus 25 is 0. So the general equation of the circle required in this problem is x squared plus y squared plus 4x minus 2y minus 20 equals 0. And this is the required equation, the required general equation of the circle. So let's move to the last problem for the circle. So this is our problem number 5. Find the equation of the circle which passes through the points 3, 5, 5, negative 2, and negative 3, 3. So to solve this kind of problem, if you don't know what to do, first is to visualize first. So locate this point 3, 5. So it's 3 units to the right there, and then 5 units upward. So 1, 2, 3, 4, and 5. So here is the point 3, 5. And then the other point is 5, negative 2. So 5 units to the right, 3, 4, and then 5, and then 2 units downward because this is negative 2. 1, 2. So this is the point 5, negative 2. And then you locate this point, the last point, negative 3, but positive 3. So 3 units to the left, 3 units upward here. So this is the point negative 3, 3. So what is the required circle? I can maybe approximate the circle that it's gonna be like this one here. There. That's an approximate drawing graph of the circle required in this problem. However, we are only given these 3 points on the circle. So how will you find the equation of the circle containing these 3 points? So in other words, it's a circle that is determined by these 3 points. Because the 3 points lie on the circle, then it satisfies the equation of the circle. So we'll say here, since this point, since these points lie on the circle, then it satisfies the equation of the circle. So at the point 3, 5, because this is a point on the circle, then it satisfies the general equation of the circle. What was the general equation of the circle? It's x squared plus y squared plus dx plus ey plus f is equal to 0. So substituting the values of x and y in the equation, so we have 3 squared plus 5 squared plus dx, so d times 3 plus e times the y, which is 5, plus f is equal to 0. So what is 3 squared? That's 9. And 5 squared, that's 25. So this is plus 3d plus 5e plus f is equal to 0. Applying simple arithmetic, I can rewrite this equation like I can combine 9 plus 25, which is 34, and if I subtract both sides by 34, 34 cancels with this, and I have to subtract 34 at the right. So this is my equation 1. Okay, Now, also, the second point satisfies the equation, which is the point 5, negative 2. So, since this lies on the circle, then it satisfies the equation. So, the equation again is x squared plus y squared. So, our x is 5, so that is 5 squared plus negative 2 squared plus dx, and my x is 5, plus ey. So, e and the y is negative 2, plus f is equal to 0. So, simplifying, this is 25 plus 4 plus 5d minus 2e, because e times negative 2 is negative 2e, plus f is equal to 0. So, applying simple arithmetic there, you can see that this 29 will be here, negative 29. And that is my second equation. Now, for the third point, at the point negative 3, 3. So, substituting again to the general equation, x squared here, because this is our general equation for the circle. So, x squared, our x is negative 3, quantity squared, plus y squared, which is 3 squared, plus dx, and our x is negative 3, plus ey, and our y is 3, plus f is equal to 0. So, this is 9 plus 9 minus 3d plus 3e plus f is equal to 0. And you can apply simple arithmetic there, that would be this 9 plus 9 is 18, will be here as negative 18 at the right. And this is my equation 3. Now, what will I do is I will write it again here, my equation 1, which is 3d. So I will write here equation 1, 3d plus 5e plus f is equal to negative 34. That's my equation 1. And my equation 2, it's 5d minus 2e plus f is equal to negative 29. And lastly, my third equation is minus 3d plus 3e plus f is equal to negative 18. So as you can see, this is a system of 3 equations with 3 unknowns. So I can solve that one in many ways. Suppose I will solve this one by elimination. So by elimination, I can eliminate f from 1 and 2. No? So solving 1 and 2. So what is my 1? The first equation, it's 3d plus 5e plus f equals negative 34. And my second equation is 5d minus 2e plus f is equal to negative 29. And if I subtract this one, so subtraction, negative 34 minus the negative 29 is the same as negative 34 plus 29. And the result is negative 5. There. And f minus f is 0. So this cancels. 5e minus the negative 2e is the same as 5e plus 2e, which is 7e. There. And then 3d minus 5d, it's negative 2d. there. And the resulting is my new equation 4. So also I need to solve 2 and 3 because I'm done with 1 and 2. So I will be solving 2 and 3. So solving equation 2 and 3, my second equation is 5d minus 2e plus f is equal to negative 29. And my third equation is minus 3d plus 3e plus f is equal to minus 18. And if I subtract these two equations, minus 29 minus the negative 18 is the same as negative 29 plus 18. And the result is negative 11. And f minus f cancels. Minus 2e minus 3e is minus 5e. And then 5d minus the negative 3d is the same as 5d plus 3d, which is 8d. There. So this is my new equation 5. So solving for equation 4 and 5, we have what was my fourth equation. My fourth equation is minus 2d plus 7e is equal to the negative 5. And my fifth equation is 8d minus 5e, which is equal to the negative 11. However, I want to cancel one variable here. Suppose I want to cancel d, so I need here a negative 8, but that's negative 2. So what will I do? I multiply all the terms in that equation by 4. So that 4 times negative 2d, I will have negative 8d. And then 4 times 7e, that is 28e. And then 4 times the negative 5, that's negative 20. And I just copy this fifth equation, which is positive 8d minus 5e, which is equal to the negative 11. And then adding, that cancels 28 minus 5, which is equal to positive 23. So 23e, which is equal to the negative 31. So what is my e? If I divide both sides by 23, my e is negative 31 over 23. That's my e. So how will I solve my other variable? I can use any of the equation, fourth equation or the fifth equation, to solve for d. So using, maybe I can use equation 4, which is minus 2d plus 7e, which is equal to the negative 5. I know what is e. So my e is negative 31 over 23, which is equal to the negative 5. And then solving, that is minus 2d, 7 times negative 31 is negative 217 over 23, which is equal to the negative 5. Now solving further, that is negative 2d, which is equal to negative 5, adding both sides by 217 over 23. So negative 2d, if you add this negative 5 and that fraction, that becomes 102 over 23. I don't want to go through the very tedious step-by-step addition of a fraction and a whole number because there's no space. Now, So my D is just equal to, if I divide both sides by -2, so this 23 will be multiplied by -2, so that becomes -51 over 23, and that is my value of D. Now I need to solve for my F. So using equation, maybe equation 1. So what is my equation 1? My equation 1 is 3D plus 5E plus F is equal to the -34. You can recall it here, the first equation. But I know my D. My D is -51 over 23 plus 5E. I know also my E, which is here -31 over 23, and then plus F, which is equal to -34. So 3 times 51, that is -153, and then 5 times -31, that is -155. And because they all have the same denominator, we just copy over 23 plus F, which is equal to the -34. So adding these two numbers, -153 and 155, that becomes -308 over 23 plus F is equal to the -34. And then if I add both sides by this number at the left and that number to the right, I will be able to get my F, which is equal to -474 over 23. So finally, what is the required equation? I can write the required equation here. I'll just make here some space so that I can write more. So the general equation formula is x squared plus y squared plus dx, but my d is there, which is -51 over 23 x plus ey, and my e is still negative, so I will have -31 over 23 y plus f, and my f is still -474 over 23 is equal to 0. That's the general equation. But what will I do is to multiply this one by 23 to remove the denominator of 23 here. So that becomes 23x squared plus 23y squared minus 15x, no more denominator 23 because it cancels with the 23 there, minus 31y minus 474, again cancels 23, which is equal to 0. And this is the required general equation of the circle for this problem. A circle that passes through these 3 points, 3, 5, 5, -2, and -3, 3. And the general equation is this. And that's it. Thank you. If you learned something today, please check out my channel for more videos like this and click subscribe. Click the notification bell below so you'll get notified whenever I'll be posting a new video. Don't forget to like this video to show your support. And always remember to math your way up. Thank you.